Okay, let's see what happens. Okay, so Dak, Harry, Marlo, can you guys talk to us a little bit about, so we all see your board. Can you talk to us a little bit about what you presented? Just go through your, show us what is your claim, what's your evidence, and then what was your reasoning?
All right, I'll just go. So my claim was that the period of my pendulum was around 2 seconds.
Okay.
My evidence was that all my trials were within 0.1 seconds of 2 seconds.
Okay.
And they were all measured at the same angle. And this evidence supports the claim because all my trials are roughly 2 seconds and I use the same angle every time.
Cool. Thank you, Harry. Dak.
No, I just went.
Oh, you just went. Sorry, Dak. So, Harry, then.
Okay, so my claim was that the average period of my pendulum was 1.43 seconds.
Okay.
And the evidence to support the claim was the 10 trials that we did and how it does support the claim because we used the same angle and made sure that every trial was accurate.
Cool. Okay. Marlo?
Mine was pretty much the same as Harry's. Claim period of my pendulum is 1.428 seconds. I could probably shorten that, but yeah. And then
Why would you want to, Marlo, can I ask you, why would you want to shorten it?
I don't know. It's kind of long.
Okay. Yeah.
My evidence is that that's the average of the 10 data points we collected.
Okay.
And then the reasoning is that I know the points are accurate because I swung the pendulum at the same angle every time I recorded a new data point.
Cool. I like it. Room 2. That's Marika, Natalia, and Timothy. Start with Marika.
So for my next, okay.
Or, yeah, whatever. Natalia, actually, if you want to go.
Sure. The period of my pendulum is 1.359 seconds because that was the average of my 10 trials. And then I also added that the median was 1.34 seconds, which is really close to my average.
Yeah. That's awesome. I love it. Marika.
The average of my pendulum was 1.703 seconds. And that was also the result of my 10 trials. And the median was 1.715, which is still really close as well.
Cool. Love it. Timothy?
So I got the period of my pendulum is 0.85 seconds since it's the average measurement. I wasn't able to add this, but the median was also 0.85 seconds, and the mode 0.85 seconds was tied for the mode.
Wow. Okay. So, you had the mean, the average, and the mode?
Yeah.
The mean, the average, and the median both at 0.85?
Yep.
Wow. That's intense. Okay. Room number 3. Molly, Ollie, Vivi. Wants to start?
I'll start. I wrote here. Hold on, mine's a little bit glitched out of the page, so I'll pull it up on Canvas.
No. Hey, zoom out. Oh, you can't zoom out. I can zoom out.
Yeah.
Let's see.
So I wrote the period of my pendulum is about 1.14 seconds. I think this because I got the average of all 10 trials and rounded it to the nearest hundredth and got 1.1 or 1.41. Making this about the most accurate representation for the period of my pendulum.
Got it. Thank you for that.
I'll go. The period of my pendulum is 1.076. I know this because I measured 10 data points, which averaged to 1.076, making it the most accurate number for the period measurement.
Mm-hmm.
Okay, I wrote a period of my pendulum is 2 full swings. The swings last for an average of 3.8 seconds. And my reasoning is that I averaged those out and making it the most accurate.
Okay, so you gave us the definition of your period, which is 2 swings, right? up and back, and then you gave us the time. That's perfect. Number 4. That's Tara Tea.
I can. Oh, okay. Oh, okay. So my pendulum swing is 1.13 seconds. The evidence to support my claim is the 10-step trial we did.
Mm-hmm.
And altogether, like the median of all the data points was 1.13. And I know this is accurate because I use the same angle.
Got it. So you said the most common number. You wrote you said the median, and then you wrote the most common number. So is that the median or is that the mode?
Yeah, it was the median.
The median. So the median was 1.13, which is the same as your average. No.
Yeah.
No, actually, what you said is that that was the most common value, period. Okay, awesome. I love it. Thea.
I said the period of my pendulum is about 1.6.
Okay.
I say this because when I put all my data together, the most common number in that data was 1.6.
Got it. Thank you for that. And then last but not least, room number 5. That would be Elliot and Vincent.
So what I said for my period pendulum, so the period of my pendulum was 2.02 seconds. I can prove this because if you average my 10 measurements together, you'll get 1.0 or 2.02 seconds.
Okay.
And then should I try and explain Elliot? Because he tried to find the formula for it. He went to a website and he found out like time equals the length times the weight divided by 1/2. But he couldn't really explain it to me. He went a little too deep, I think.
Where is Elliot?
I don't think he had internet problems.
He had internet problem. Got it. Okay, so welcome. So this is our first whiteboard meeting, right? We will have many of those whiteboard meetings. This is how we work. Like whiteboard meetings is the meat and bone of the method that we teach here at the Bay School. The first part of the whiteboard meeting is sharing the whiteboards. So that's what we've just done, right? The point of the whiteboard meeting, the goal of the whiteboard meeting is twofold. Number one, it's to get clarity, right? So that if you came into this exercise either not understanding something or being unclear about what the deliverable would be or what I meant or anything like that, anything about the topic, that you need to, at the very least, at the end, you need to have clarity. So you need to have asked questions, right? And the second one is to reach consensus. And consensus means that, so consensus can be a variety of things. One is it could be that, we all actually have the same information, which is never going to happen, right? Like my favorite exercise was a professional training I took. There were 30 chemistry teachers solving a pretty simple chemistry problem on a whiteboard. And we all had a whiteboard. We all solved the same problem, exactly the same problem. None of our whiteboards looked the same. Not a single one of them, right? So I don't think we'll ever have the same whiteboards. And if we don't have the same whiteboards, then consensus can mean, can we agree to disagree? Like, is it okay? For example, we were all said, like, what's the period of your pendulum? You all found a period, right? So if you look at the numbers, it looks like Elliot found 16.7, whereas Vincent found 1.2, Tara was 1.1, Thea was 1.6, 70 was 1.07, 1.4, 3.8, 0.85, 1.35, 1.7, 1.43, 1.43, and 2. Okay, so we found very different numbers. So one issue is, one thing that's interesting to note is, should we all get the same numbers or not? Like that's a question we should be asking ourselves. The second one is, one thing I want you guys to think about and learn from each other, right? And learn from each repetition is sort of like, how do you best make your point? So some people gave an average, some people gave a mode. Almost everybody, except for Elliot, said that they were supporting their claim using the 10 trials. Do you guys see something that's missing in almost every board? In every board, in fact? Look at the boards. This one, that one, this one, this one, that one. What do you think is missing? What would make those boards even better? What would make the argument even more persuasive, I guess? Yeah, Vivi.
Reasoning.
What do you mean by that? Because I think you gave me some reasoning, right? Didn't you guys give me some reasoning?
Yeah, like a little bit, but like more in-depth reasoning.
So what would make the reasoning more in-depth?
The logical connection between a claim and evidence.
Okay, so that's Vivi's opinion. What do you guys think? What the rest of you think? Yeah, Oliver.
Maybe the data itself from all 10 trials.
Right? I mean, you guys all tell me, like, my 10 trials together, when I average my 10 trials together, the answer is 1.202. I'm like, I want to believe you, right? And I trust you guys generally, but, like, it would be nice to see the data. Like, it would be nice to see the data. I didn't specifically ask for it, but one thing we just learned is that it will be more persuasive, your argument will be more persuasive if you can actually show me your data. How are some different ways we can show the data? Yeah, Tara.
Maybe like copying and pasting the data in.
So you can copy and paste the data in. So in what form then? What form would that take? Would that be a list? Would that be a table? Would that be a graph? Would that be, what do you think?
A table, probably.
Maybe a table. Would it be okay to make a list of all the data points that you have? Would that be an effective way of showing your data? And the answer is yeah, absolutely, right? So a table would be great, Tara, right? But a list could work. A graph could work. You'd have to think a little bit about what graph you wanted to show, but that would be, right? And I also want to talk a little bit about, so Elliot, went off the deep end, and he went online and found a formula. Question, is that a legitimate thing to do?
Yeah.
Always, right? Always, right? We're not going to pretend that the internet doesn't exist. We're not going to pretend. One of the things that, as a physicist, I want you to learn, as a scientist, is that research is key, right? So if you ever wanted to go online and research information about what is something that I'm asking about, you should always be able to do that. However, one, if you're going to use a formula, you need to use it properly, right? And two, you need to make sure that you understand what you're using, and you need to make sure that your data supports, right? You need to make sure your data supports what it is that you're using. So it's interesting, if you look at Elliot's explanation, he said that, so let's read the sentence together, right? It said, I learned that to calculate the period of a pendulum, the formula is T equals L divided by G divided by 2. Or multiplied by 1/2, yeah, divide by 2, right? Where I'm assuming T is the time, so that would be the period, L is the length, and G is something, which we don't know what that is. Anybody has any idea what G could be? In what context have you guys heard about G in physics? Or have you ever heard about G in physics?
Is it gravity?
Yeah, it's gravity, right? It's the acceleration of gravity. So it's interesting, right? He already had an average time. So he said, before plugging in this formula, I had to learn that my pendulum had an average time of 1.136. What is that average time, by the way? What do you think it's a time of? The time of what?
Period.
Yeah, it's a period. So it's interesting. He already had the period, 1.136. And then he used the formula and he figured out this pendulum, that this period was in fact 16.7, right? So that's an interesting, so then the question is like, is that his period, 1.136, or is that his period 16.7? Okay, and that's something that he needs to think about. At some point, can't remember who it was, somebody said, it's a little long, right? The numbers were a little long. So 16.725, that's like 5 digits, right? 1.202, that's 4 digits. If you look at other boards, right? 1.41, that's 3. 1.076, that's 4. 3.8, that's 2. 1.39, that's 4. Question for all of you is so if it's too big, how big is big? Like what should be the right amount of digits? What do you think? Who was it who said it was too big? Do you guys remember that?
I don't know who said it was too big, but maybe to like the hundredths point.
Okay. What do you think? Marika, what do you think? Hundredths, a tenth, a thousandths? How do we know?
I think hundreds is a good place to stop,
Okay.
or else it might get too confusing. And, yeah.
Could be too confusing. Natalia, what do you think?
Well, I think the more numbers you have, like the more accurate your like evidence can be.
So
I would say that
like full hop, like
yeah, I would say like include as many numbers as you can, but I don't know, maybe like a limit of like 5 or something.
so as many as you can, but no more than 5.
Yeah, exactly. I guess it kind of depends the situation, because like I guess for seconds you can kind of go to like the hundredths.
Mm-hmm. Why can you go? By the way, Natalia, I really agree with you. I think that's a really good point, right? It depends. What does it depend on?
Just like what you're measuring, because for some things you have to be like really exact and precise in order to like how would you say, in order for your experiment or something to go well. But for other things, it's like okay to have an approximation.
Interesting. Dak, what do you think about that? So Natalia said most of the time hundreds is okay, but it depends. It depends on what you're measuring, because sometimes you have to be super precise and sometimes it's okay to be a little bit off. What do you think, Dak? Dakota, you're with me?
Mm-hmm.
So what do you think about Natalia's statement?
Yeah, it's fine. Yeah.
Oliver, what do you think?
Well, I think it depends on the circumstance. I think a lot of the times it's good to keep it in either the hundredth or thousandth place, just to make it more digestible, so it looks like an actual fact versus, just a bunch of random numbers. At least that's what I found with myself, is I can actually interpret the number if it's, smaller versus larger. But I think I think there are circumstances that you would want to make it longer. but I think for the most part, you should keep it in either the hundredths or thousandths place.
Got it. Okay, so I don't want to belabor this right now. It's our first whiteboard meeting. This would be really cruel. This is a really, really important issue, right? And we will revisit that issue a lot. I think the comment that Ollie made about the number needs to be understandable makes a lot of sense to me. I think Natalia's comment about it really depends on the circumstance. Natalia said the circumstance depends on what you're measuring, right? Some things are really important to measure precisely. Some things you can be a little bit off. That makes me feel bad about the data that doesn't need to be measured very carefully. Like, I'm not exactly sure what data do you think, Natalia, needs to be measured not very carefully, but I think all data being, all data matters, right? And so all data should be measured carefully. But I think you're right, it does depend. I'm not sure if it depends on what you're measuring or it depends on what you're measuring with, right? So if you measure with a really precise ruler, then you're going to have a really precise result. If you're going to measure with a ruler that's like a matchstick, right, then that's probably not going to be super precise, and everything in between. So. Okay, so at this point, I'm going to do a couple things. One is, let's see, the heck. Okay, hold on a second. So I'm going to stop sharing. I'm also going to stop recording.